Good evening, students, and I welcome you for another very important topic. Important chapter is on the board, students. Coordination compound, students. What we are going to discuss, students, coordination compounds. So we must understand what are coordination compounds, how they were discovered, and who is the father of the coordination chemistry, students. Lot of important information is there, but you know already when I discussed the properties of the transition elements, what did I tell you? That transition elements form large number of complex compounds. We told you when we were talking about the chapter of the transition elements, students, what we told you about the transition elements, that they form
Large amount of complexes.
large number of complexes. Important that they were forming large number of complexes. The question is, what is a complex salt? But before that, I think it's important to understand what is a salt, students. Now I'm coming to certain basic question. In chemistry, what is a salt? What type of salts you already know? How a salt is formed? You are aware of acid plus base gives salt and water? Yes or no? Tell me, are you aware of it? The formation of salt.
Yes, sir.
One of the first thing I am talking is a
Yes, sir.
simple salt, student. What I am saying, simple salt. What do you mean by a simple salt, student? For example, if I say NaCl, sodium chloride, students, this has got, if I put it in water, what happens? If I put it in water, the salt will ionize, and what do you get?
Yes, sir.
Sodium ions and chloride.
And plus chloride ions.
So you are getting one cation and one anion, one cation and one anion. This is the simplest situation. You can take NaCl, you can take KCl or magnesium sulfate. So many other compounds which are salt, students, they will be ionized and will produce ions in the solution. Or they split up, and in this case you will be able to get these ions can be identified easily. Ions can be identified, student. Can they be? By a test? For example, if you have chloride ions, if you add silver nitrate, what happens? You know what happens? You will get a precipitate of AgCl.
Yes, sir.
Okay. So there is a way to identify these ions. So they are ionized. These are simple sort. Then you have also found in chemistry, they are talking of student double salts. Double salts, students.
Yes, sir.
Do you know any example of a double salt, student? Any double salt?
Yes, sir. More salt.
Oh, what is the formula of the Mohr salt?
More salt. It's FeSO4. Uh, NH4 whole twice SO4 dot
Interesting thing is
some
that if I have two simple salts, if they combine, if I add two simple salts, students, how it is done in the chemistry lab, you can add them, evaporate them, and then crystallize them. You can get, there are two simple salts, they have combined here to form a double salt. So it's also a type of molecular addition product. So you have ferrous sulfate, ammonium sulfate. This example, this is a Mohr salt which we use in chemistry lab for the titration of ferrous to ferric. Has any experiment been done in the labs nowadays? This year, any experiment? No,
no, sir.
no science lab anywhere. Huh?
No, sir.
I don't know what will happen. So ferrous sulfate, ammonium sulfate. What is the story? As soon as you put them in water, students, if I put them in water, what will happen, student? What will happen if I put them in water?
Dissociate.
They are ionized and will produce, here you are going to get more than one type of cation or more than one type of anion. You can see that what type of cations you are getting, and water of crystallization, water is also present. So what is happening, students? As soon as you, these are in the solid form, you have a salt, how you put in water, the ions ionized, dissociated in the water. And once you get ions, if you get only one cation or one anion, that is simple. If you get more than one cation,
It is double
double.
salt.
So, but important thing, they will maintain their identity, students, because we can do the test of them. You can test them. You can add barium chloride, you will get barium sulfate. You can test for ammonium ion. You can test for ferrous ion.
Sir, in double salt there can be more than one, more than two simple salts also.
Well, if we can form them, we can do it. But most of the times, what we have experienced, there are two salts which we have experienced. Some of the examples we have given here. Double means two salts together. It will be difficult to make a salt which have three or four or higher than that.
Okay.
Crystallization and all that process. But
Okay.
the double salts are very well known in chemistry and they are prepared. They, you already know, carnallite, you are aware of carnallite. What is
Yes, sir.
carnallite? Is a double salt, student, carnallite.
Okay.
Here we have given few examples of the double salt, students. Carnallite. This is our carnallite. What is the formula? KCl MgCl2 12H2O. This is the example of the carnallite. Therefore, students, this will get ionized, will give potassium ion, chloride ion, magnesium chloride. There is more than one type of
Yes,
cation
sir.
which is present. They are called double salts. And we also know what is this producing? Potassium ion, chloride ions,
To the Mg ions.
Mg2 plus, and to be more
To
specific, I'm writing AQ, aqueous, aqueous, aqueous. Similarly, these are aqueous, students. So what we have, they are all aqueous because they are ions in the solution. These are well known, what we have told.
yes, sir.
Potassium, potassium, aluminum sulfate, and 12H2O. So they will be completely dissociated when you dissolve them in water. But there is a complex salt. What is a complex salt, students? It is also a type of a double salt, but behaves in a different way and could be prepared. It could be made from these when you have more than one salt. If you mix more than one salt, you may get, students, a complex salt. Why do we call it complex and what is the difference here? Here, for example, if I say, if I write a compound which is so well known,
One,
K4FeCN6,
four,
students.
six. Okay.
This is potassium ferrocyanide, you
Cyanide.
know, in chemistry lab. It's quite
Yes, sir.
a colored compound. Now, if you will put it in water, students, what you will get basically, you will get these ions. This is
Okay.
4 plus or this is 4 minus ions. Now, what is
Oh,
happening here? This, what is the story here? This cyanide ion, you can see that there are six. Okay, I'm putting six. This CN students, as you can see, is not going to ionize. This, whatever I put in the bracket, students, what I have put in the bracket is just behaving as one entity. It is not dissociating. This is not dissociating in water. This is not dissociating in water. Students, important point that here the identity is not there. It is lost. They have lost the identity, students. And therefore, how it is formed, it is also formed from FeCN or KCN. There are two things, potassium cyanide and the cyanide of iron, by mixing these two. But you can see that now the CN is behaving in a different way. This ion is there, this one. What is outside the bracket, student, that is forming ions. But no ions are formed by this CN and iron. Therefore, student, this shows that it is a different type of salt. This is a different type of salt. This behavior is totally different. It is not dissociating into Fe2 plus and the Cn minus ion. This dissociation is not taking place. It is not dissociating into these ions. Such compounds, student, are called coordination compounds or complex ions. Such compounds are called what we call as complex ions, complexes. This is not a ordinary ion. This is called a complex ion, or these are called coordination compounds. Students, what we are discussing, the topic is coordination compound.
Coordination compounds.
असल में it is not the story is that long back they were aware of certain compounds which were very colored, but not much was known actually about the bonding in such compounds or what type of bonds are present in these, and nothing was known about the structures of these compounds. What are the structures of these compounds? But we know
Okay.
today the chlorophyll which is present, you see, chlorophyll, hemoglobin, and vitamin B are also coordination compounds of magnesium, iron, and cobalt. Biological also these
Okay.
compounds are important. In hemoglobin, you know, you have iron, chlorophyll, you already know magnesium, and vitamin B12, cobalt. They are coordination compounds. So, in large number of metallurgical processes, we are using coordination compounds, and in industrial as catalyst, as analytic reagents. Also find applications in many other areas of chemistry like textile, dyeing, medicinal chemistry, electroplating. So, what is the important thing about them, student? Then, how this were discovered? That point is important. Interesting thing is that the entire discovery of coordination compound goes to Werner. What we are saying? Student Werner. And it is known is his name Alfred Werner. He was a Swiss chemist, was awarded Nobel Prize in chemistry also for his work on coordination compounds. Interesting thing is what happens, students. For example, students, if I consider COCl3 compound, if I consider COCl3, or if I consider, students, COCl2 compound, these are some compounds. If I consider palladium chloride, these are all transition elements, as you can say cobalt, palladium, chromium. These are what type of compounds are these? If I put them, they will ionize. How it will ionize? It will give CO3 plus.
CO3 plus and 3Cl minus
What it will do? CO2 plus
and 2Cl minus.
2Cl minus, students. This will give what? Cr2 plus.
Cr2 plus 2Cl minus.
So these are forming ion, student. What we say, they are nothing but simple type of compounds. or simple salts. So here you are getting cobalt 3 plus, cobalt 2 plus. This, what is this? 2 plus, 3 plus, what are these known as? These are the oxidation numbers. What are the oxidation number of cobalt here? You are saying cobalt here is 3
3. 3 plus.
and cobalt 2,
Okay. Is 2.
chromium 2.
2.
This is also called the valency of the metal ions.
Okay.
In these compound, student, one thing you can observe. The valency of cobalt in COCl3 is 3 and the compound is COCl3. In this, the valency of palladium is 2. This compound will, these are simple compounds. These are simple compounds. Interesting thing was Werner was performing some experiments, and what he was doing, he took students COCl3 compound. What is it? COCl3. And he reacted this with ammonia. What he was doing, he was reacting this with ammonia. Cobalt, this is my cobalt 3 chloride. ठीक है? And he
Yes, sir.
reacted this with NH3 molecules. This is a simple molecule. NH3, what type of molecule? It is a simple molecule, NH3. And it was found that he could prepare more than one type of compounds. What he was getting, if he changed the amounts of NH3 students with the COCl3, he was getting more than one compound, more than one compound with ammonia. And these compounds were having different properties, as color was different, conductivity was different. So different compounds were obtained, different colors, different colored compounds were obtained, and their properties, at that time he could measure the properties like conductivity. What he was measuring, the conductivity of the compounds, or if there is a Cl minus which is present here, you are getting Cl minus. So he was trying to precipitate the Cl minus chloride ions by silver nitrate. What he was doing, he was precipitating what, Cl minus
Okay.
with silver nitrate. By this way, he was trying to find the moles of Cl minus, moles of Cl minus. So what he was finding, that different amount of AgCl were obtained. Different amounts of AgCl were obtained, students. This was something amazing. I mean, because interesting thing to understand here is, why will you get more than one compound? First of all, why will you get more than one compound? Second, these compounds were having different properties. And we know in chemistry, we have learned about there is a valency of every element. You are saying, what is the valency of an element? That you are saying, oh, combining capacity is defined as the valency.
Yes, sir.
And if there is only one type of valency, then one compound should be found. But if there is a more than one type of valency, students, then more compounds will be found. Or in other words, you can say that in these compounds, the valency is changing. That means there are compounds of ammonia with different valencies. Therefore, different compounds are being formed. Different compounds are being formed. So, students, this was very interesting thing at that time. Nobody was able to explain. Earlier also such compounds were known. They have known more than one compound of COCl3 and ammonia of different colors, but nobody understood the type of bonding which is there. For example, here you can say series of compounds of cobalt 3 chloride with ammonia. And this is my COCl3. When reacted with ammonia 6 moles, 1 and 6 of this, what he was getting, what he got was a, as we can see here, yellow type of compound. This is a yellow
Okay.
color. And on precipitation with silver nitrate, it produces 3 moles of AgCl, which will give precipitate with chloride ion, student, silver nitrate. But another one, as you can see, ClCl3 plus 6NH3, you are getting a compound, student, which is COCl3 6NH3. What is the color? Yellow. A question has been put in the board on this basis. So pay attention what I am saying.
Yes,
And
sir.
with silver nitrate, student, whatever at that time things were available, they were performing experiments, precipitation. They were getting 3 mole of AgCl.
Okay.
This indicates that it contains 3, what it shows? It contains 3
3Cl.
ionizable, I am saying, ionizable
Okay.
Cl minus. Something which is free in the solution, that will precipitate.
Yes, sir.
If it is forming a bond somewhere, then it is not available. It is not available. And in the second case, as you can see, student, what is in the second case, you are having COCl3 and 5NH3. The ammonia has become one less here. You can see this was yellow and this was purple in color. And when experiments were done, student, it gave 2 mole of AgCl. That means how many ionizable Cl minus 2.
2.
Here 3 Cl minus ionizable. I write it here, students. Ionizable Cl minus. How many you are getting here? 3. Here you
3.
are getting 2. Here
2.
1. Here
1.
1. 1.
1.
So how do we explain this? That was the point. Color, you see, one yellow, purple, green, violet, different colored compounds are being formed, having different properties. So this was the question before Werner,
Okay.
and he was thinking to solve this riddle, and then he proposed that there are two different type of valencies in these compounds. And now I am saying, because such a knowledge of chemistry is there, we don't know what valency is in 10th or 11th or 12th and what chemistry we are learning. So I'm pointing out now, see, everything is so important. So he proposed that there's a more than one type of valency. And if only one valency is there, then one compound should be formed. Now more than one compound is being formed. So this is important idea. If we know the 10th class valency, then we understand, yes, something is happening. Therefore, students, there is some connection between the valency and the compound, or there is some structure or bond which is being formed by certain you see molecules with the cobalt. Cobalt is a transition element, so that
Okay.
they don't become free. What don't become free? Cl minus.
Cl minus.
And as you can see, it's only COCl3, 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 but they are not producing 3 Cl minus in all the cases. They are not producing in all the cases. And on this basis, Werner proposed what he says, his theory of coordination compounds. This was the experimental information. Students, he measured the conductivity also. He also measured the conductivity, students. Conductivities were measured. What do we get from the conductivity? Tell me, in chemistry, if I measure the conductivity, what do you get, students, from the conductivity? What will I
Mm,
obtain from the conductivity, students? that he could find out the number of ions. Number of ions,
Okay.
students. Conductivity depends on number of ions. If the number of ions will change, what will happen to the conductivity?
Will change.
Conductivity will change, students. And after this experiment, what is being said, student, that this compound, which I am saying yellow, students, he said, okay, he proposed a formula for that. He said it is something like this: CO NH3 6 3 plus and 3Cl minus. What did it mean, students? What did it means? This Cl is outside the bracket. Is it outside the bracket?
Yes, sir.
These are free. These are free. These are ionizable.
Okay.
And silver nitrate I will add. What will happen? It will precipitate this. It will precipitate this. If this compound is yellow, if this has this formula, student, there will be three chloride ions which are ionizable, students. So these are ionizable, and he calls this as a primary valency.
Okay.
Primary valency, students. And you can see that what is the oxidation number of cobalt here?
Oxidation number of cobalt is
Oxidation number of cobalt is, students, +3.
+3.
So the oxidation number is also the primary valency. The same thing I told here also. Did I not say cobalt +3? I have shown
Yes, sir.
in COCl3. In COCl3, students, COCl3, what is the oxidation number of cobalt?
+3.
COCl3 +3, and this is my primary valency. This is the primary valency of cobalt.
Yes, sir.
But there is another valency now. There is another type of valency also now. What is happening to these ammonia? These ammonia molecules are not free. They are now attached with or forming what we call as a coordinate covalent bond with the cobalt. They are forming, students, a coordinate covalent bond with the cobalt. This, in the whatever I write in the bracket, student, they are not ionized. These are not forming any ions. They are not ionized, and this is what he calls secondary valency. Secondary valency. This is called the secondary valency, students. These are the two
Okay.
linkages. One type of linkage is primary and other is secondary linkages. That's what we are trying to propose now. This is also called the coordination number.
Okay.
We are going to explain everything about this, but here we are just trying to give you, you can note down all these points are very, very important, students, how
Yes, sir.
the coordination compounds were discovered. So basically, the cobalt COCl3 has been studied a lot by adding ammonia. But if I add different moles of ammonia, you are getting different compounds.
Yes, sir.
In an attempt to explain that, Werner was thinking, and he solved this problem by saying that these are not the simple compounds or double type of salts which we are talking about. These compounds, you can see there are two things, ammonia and this. It looks
Yes,
like
sir.
something like a double salt,
Yes, sir.
but these are not double salts. These are complex compounds, coordination compounds, in which the ionization takes place in a different way. You are getting a cation, and
An
you
iron.
are seeing the other part is, what is the other part? That this other part, students, is not getting ionized. Ammonia molecules are
Not getting ionized.
not getting ionized free. That means they are forming a bond with cobalt, student. And what type of bond we are going to tell you? This is a coordinate covalent bond. and ammonia molecules are known as ligands. Student, ligands, we're going to discuss all these things. They are donating their lone pair of electrons to the cobalt. Cobalt. Cobalt is in 3 plus oxidation state. Cobalt is in 3 plus oxidation state, students. So this was one experiment.
Okay.
This experiment has been asked in the paper in a particular way. Question will tell you what type of question. Do you have any doubt in this?
No, sir.
I always tell to the students, understand everything.
Yes, sir.
They have asked what is the difference between double salt and a coordination compound also. So you have seen what is the difference coming. We know that the double salt is going to completely dissociate into
Completely
ions,
ionized.
and the ions can be easily tested and they will maintain their identity, students. But here what is happening, this identity is not there in this whatever I am writing in the brackets. They are not
It will not
dissociating
dissociate.
into cobalt and ammonium ions.
Ammonium ions.
Ammonia and cobalt, you are not getting out of this. Okay, what more is important? See, I'm expecting one question on this, so that is why I have given more time on this. Okay, PTCl4, platinum is a transition element.
Yes, sir.
I'm saying transition element. What he was doing, he was adding ammonia
Okay.
and preparing the compounds of PTCl4. What do you do? Mix what you are mixing, NH3. You can use 6NH3, students, 5NH3,
4NH3.
4NH3, 3NH3, and when 3NH3, when he used 2NH3, no compound formed, nothing.
Okay.
And he was calculating the number of ions per formula unit. Per formula unit, how many ions will be there? He obtained these ions. How many? 5 ions in the first case, 4, 3, 2, and 0 ions. No ions here. So what is happening? There is no ion here. No compound is formed, but no ion. I mean, he is able preparing these complex. These are complexes. Okay. So
Yes, sir.
what we are saying, number of ions here 0, and he then reacted them with silver nitrate to find out the how many number of chloride ions are present by precipitation reaction.
Okay.
How many chloride ions were present here? Number of chloride ions in first case 4,
4.
3, 2, 1, 0. Conductivity measurements were done. Units you have no ohms inverse, and these conductivity measurements also indicate that there are 5 ions, then only conductivity is 523 ohms inverse, 404, like this. So this experiment is done. So how do we explain this? Same story which we told you in the previous case. That also what we are saying.
Okay.
Now that there in the here what will happen, student? If I say this is PTCl4 6NH3. Okay?
Yes, sir.
Let me take some. Now we are saying how many ions it is forming? 5.
5.
So what we are proposing that this has something like this. And how many you have? Cl4. Something like this. We are saying that inside this you have, or I should write it in a different way. Actually, it's not written like this. I am saying Let me say, I'm putting it in different way, student. Let me say, there should be no confusion because otherwise, what will happen, students? Okay, let me. I'm putting it 4 Cl minus. I'm saying. ठीक है? That
Yes, sir.
means, students, that this platinum has got 6 NH3 molecules joined with platinum, forming some bond. And these, when I write outside the bracket, these are free.
Yes, sir.
As soon as you will put in water, they will just go with the water. They are inside, but they are not coming in the water. So
Yes, sir.
you will put AgNO3. What will happen? You will need 4 of this to form 4 of AgCl. That is what you are getting, number of chloride ions. And if you measure the conductivity, what is it coming? 523 ohm inverse. What it means, how many ions are there, student, here? How many ions are present in this case? If I write like this, what is the what is the charge here, students? This is 4Cl minus, then what will be here? 4
4
plus.
Cl minus.
4 plus.
Yes, sir.
Are 4 plus and 4 minus
Yes,
will
sir. Yes,
become
sir.
0. This has no charge, na? This is neutral.
Yes, sir.
This is neutral. Okay. So, what is the total ions then?
Uh, Total, there would be 5 ions
This is only one ion. Charge is 4 plus, and this
and
is
there are
4,
4 C chloride ions.
5 ions. So the
Okay.
molar, what you are getting, conductivity 523 ohms inverse, and this we have written number of ions per formula unit. What happened in the second case, student? You are saying PtCl4 5NH3. How many
Yes, sir.
ionizable? Cl minus 3.
3 C.
So what is the story now? That means, students, you have
PT
5 and
NH3
Cl
whole 5
and
3
3
Cl
Cl
minus.
minus. 3 Cl minus.
Yes, sir.
Still there are 6. These are called the ligands. We will tell you. These are called the ligand. There are still with platinum. How many are forming bonds? 6
6. Yes,
molecules.
sir.
6, 5
Yes, sir.
NH3 and 1 Cl. 5 NH3 and 1 Cl,
1 Cl.
students. How many here? 4, 4 Cl minus were free. How
4
many
C.
are free here?
3 Cl
3 Cl minus are free.
minus.
3 Cl minus are free. Then how many you will get? 3 AgCl.
3 AgCl.
3 AgCl. And what is the total number of ions here?
4.
Okay. Total number of ions you are saying is how much?
4.
One. This is, I will 3. So 3.
3 Cl plus 1 this whole big.
Okay.
Yes, sir.
1 and 1 plus 3. 4 ions. 4 ions. And students, I am coming to the next one. PtCl4. Their color must be different, which I have not given because they are different compounds. Somewhere you will get the information about colors. So PtCl4 and 4NH3. What happens? Platinum NH3 4, and you are getting Cl2.
Cl2 and
Cl
then 2Cl minus.
2Cl minus 2 plus. How many free Cl?
2, 2,
So you will get 2 AgCl. What is the total number of ions?
3,
Total number of ions. How much?
3.
1 plus 2, 3 ions. And what is the next one? PtCl3, 3NH3. What it will be then? PtNH3, 3Cl3,
Cl3, yes, sir.
3
NH3 whole 3, Cl3 and Cl minus.
plus and Cl minus.
Cl minus.
So only one.
1 AgCl.
What is the number of ions?
2.
And in the last case, what you are getting? Neutral? Neutral?
Yes, sir.
Nothing. NH3 how much? 2
2
Cl4.
Cl4.
So there is no free Cl, zero ions. Now on this basis, students, Werner proposed his postulates or Werner's theory. What he says, the metal ions have two different kinds of valency, student. That's what I'm saying. If they have only one valency, then only one compound should be formed. They have two different kinds of valency, students. One is the primary valency, which is the oxidation state of the platinum. What is the oxidation state of platinum in this compound? What is the
Uh,
oxidation state of platinum? Here, ammonia is a neutral.
on plus 4
Ammonia
in
is a neutral. And Cl, oxidation state -1.
minus 1.
So on this basis, if you calculate what is the oxidation state of platinum here, +4.
Plus 4.
What is the oxidation state of platinum here?
It is plus 3.
+3. Just
In
check it out. I knew you will do a mistake.
okay. Okay, one Cl is inside also.
How do you
It
calculate?
is
That was the point.
plus 0 minus 1 is equal to
How do you calculate, student? If I
x
give you this
minus 1 is
compound,
equal to 3, x is equal to 3
what is the
plus 1
oxidation
whole
state of platinum? If it is X, this is 0,
0
and this is
and this
minus
minus
1 is
1.
equal to +3, then X is
It will
equal
be
to
3 only.
3
And 4, not 3, 4.
+4. What is the oxidation number of platinum here?
Uh, it will be x plus 0 minus 2 is equal to, which is just 2. X minus plus 4.
Everywhere it is +4. That
Plus
is
4
why
only.
I gave you, students. I knew if you don't work out, you are going to do mistake in the paper. It's very important. Why do we do so much hard work? Because we want to be clear what is happening here. By NCRT writes only 5 lines and the chapter is over. What will you do? You have to understand everything. This when I will write their IUPSC name, everything will be important. This will be counted. That's why we are putting all efforts here.
Okay.
This is the primary valency here is how much then? The primary valency here. What is the primary valency? 4.
4.
Is it changing? Is the same here in all these.
Same.
In the compound, when I say PtCl4, I said what is the valency of this? You are saying platinum 4. Is it not platinum 4 here? Tell me.
Yes, sir.
In Roman letters, we write like this.
Yes, sir.
Platinum 4. PtCl4 means platinum 4. Now I am adding ammonia. And what is happening? One is a one valency, I am saying that platinum oxidation state is its primary valency, that is 4. And second valency is, he is saying secondary valency. Now he defines another type of linkage. These are two different linkages, different valencies. He is saying secondary valency. And
Okay.
what is the secondary valency, students? The secondary valency is what we said are equal to what?
Coordination number
Coordination number here. That is here how many are there which are joined with platinum? 6.
6.
So here you are getting secondary valency of 6 students. 6 ligands are
Okay.
there, which these are electron donors. Actually they are Lewis basis students, they give their electron pairs, and these are transition metal ions, they are accepting the lone pairs of electrons from these molecules. They can be neutral or they can be negative ions. So we are saying primary valency is the oxidation state and secondary valency the coordination number, that is the total number of ligands bound to the metal ion, students, metal ions. And secondary valency is satisfied by these ligands which are giving their lone pair of electrons to the central metal ions. ठीक है?
Yes, sir.
And those which are outside, they are free, they are free student. ठीक है? Primary
Yes, sir.
valencies are ionizable.
Ionizable.
This primary valency is ionizable, means they are producing ions. In this case there is nothing, no ions are there. Is there anything outside? No.
No.
So if it is, if something is there, it will ionize, otherwise it is not. So there are two types of valency, students. Secondary valencies are those valencies which are written as what we are saying coordination number, or those ligands which are donating their lone pair of electrons to the central metal ion. And primary valency is the oxidation number. Oxidation number. Now this is clear. We can remember easily the
Yes,
difference
sir.
between primary and secondary valencies.
Secondary. Yes, sir.
Okay. What we try to say, what my meant is, student, for example, here also in this compound also you can see that there are two type of linkages. Coordination number is 6, because in these compounds what will happen, the formula, if I write their formulas, you will see what is the formula of the first one.
It is
CO
COCl3 dot 6NH3.
6,
It
and
will be
how many Cl are outside? 3 L minus,
CONH3 whole
and
6
this is 3
and
plus, 3 plus.
3Cl minus.
So here you can see that what is the oxidation number.
Oxidation number 3.
Oxidation state of cobalt is 3. That is the primary valency.
Valency.
Primary valency. And what is the coordination number?
6.
6. That is the secondary
Valency.
valency. And for you can write the formulas of all those.
Yes, sir.
So this is the, we are saying there are two types of linkages. Werner came to the conclusion there are two type of linkages, and experimentally information is available. How many ions are there? How many Cl minus will be precipitated? And what is ionizable is outside the bracket. Outside the bracket, student, you can say.
Yes, sir.
So those which are outside, they are the primary valencies. Primary valencies, which are ionizable, and they are usually satisfied by negative ions. You see, they are negative ions. What are these? Primary valencies are satisfied by negative ions, and you are saying they are ionizable.
Ionizable.
This is the theory which is proposed by Werner.
Okay.
And more important point is that since you can see there are 6 ligands which are attached to this platinum, and these whatever we write in the bracket, students, these secondary linkages to the metal, they have definite spatial arrangements. They have definite spatial arrangement, student. What they have? Definite spatial arrangement based on coordination number.
Coordination number.
If coordination number is 6, Werner says that the shape is octahedral. You have
Okay.
seen sp3d2 shapes,
Yes, sir. Yes, sir.
octahedral. So in such cases, we are saying coordination number is 6. The shape is octahedral. Means what? The secondary valencies are oriented. This is my C. How many? If I write NH3, students, NH3, 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 ठीक है? This is my NH3. NH3. These are forming coordinate covalent bonds. What is
Okay.
this Cl has come from me? I'm saying NH3, NH3, and there are 3 Cl. Those 3 Cl could be anywhere. They are free. See, they are free. They are not bound. 3 Cl minus. Okay? So this is what we are saying. There are 2 types of linkages: primary and secondary.
Primary and secondary.
The ionizable is equal to the oxidation number primary. These are the
Primary.
secondary. And here you are saying that there is a lone pair of electron, lone pair of electron, lone pair of electron, lone pair of electron, lone pair of electron. They are donating it to cobalt. Okay? And now the slowly, that is why they are forming coordinate covalent bonds. They are not ionizable. They are non-ionizable.
Okay.
That's why they are linked. These are not linked Cl minus. So you are precipitating them. You are precipitating them. And why such a coordination compounds are formed, that secret is also now clear to us. Clear to us.
Yes, sir.
Why? Why they will form? Why? These are the transition metal ions. These are the transition metal ions, students. They are forming complex compounds. They are forming complex compounds.
Complex
Why?
compounds.
Why then? Question. What is your answer, students? What is the reason? Because you are saying there are ligands, they are giving their electrons, but they will, when something gives electron, there should be someone to take it. Who will take the electrons? Who will take the electron? Then they have small size. Which one? Transition metal ions.
Transition metals.
High charge, high positive charge,
Charge.
student. If you have a high positive charge, you will attract the electrons more strongly,
Electrons.
and there should be vacant orbitals. If you don't have vacant orbitals, where the electrons will go? Nowhere. Can they go in S or P? They already filled. Then where are the vacant orbitals in the transition element? 3D or 4D
3D and 4D.
or 5D, whatever we take.
5D.
These D orbitals are there. S orbitals are there. P are there. D are there. And so on. See? So that is why when hybridization took place, you are saying sp3d2. If D is vacant, then only electron will go there.
Yes, sir.
If it is not vacant, then how the electrons will be shifted? So that is why the entire coordination compounds, you will get all the transition metal ions. You are talking of nickel, you are talking of cobalt, you are talking of iron, all these transition elements, platinum. Are we
Okay.
talking of any alkali metal?
No,
No.
sir.
So palladium, nickel, cobalt, platinum, all these they are forming students what type of compounds? Coordination compounds. And that then Werner said ki they if coordination number is 6, they are octahedral. These have been proved later on experimentally, student. If I write something na, at that time lot of experiments were not available, but he is proposing his postulates, and there is a whatever experimental evidence he was using at that time is only precipitation by the silver ions and conductivity measurements.
Yes, sir.
Today there are so many other methods of uh, experimental techniques and instruments are there to verify what he said, is it
Okay.
clear?
Yes, sir.
So here we know that if the shapes of these, if their coordination number is 6, student, they are octahedral in shape.
Octahedral.
And for example, a question is here: on the basis of the following assumption made with aqueous solution, assign secondary valency to metals in the following compounds. The compound is PdCl2, PdCl2, 4NH3, 4NH3, and he says two
PdCl2.
moles of AgCl were precipitated. What is the secondary valency? What is the secondary?
PdCl2 dot 4NH3. Okay. So it will be
PdCl4NH3.
PD
How many chloride ions
NH3
were there? 2Cl minus.
2Cl minus
Will require 2 Ag plus.
2 plus.
So you get,
Secondary valency is 4.
that means that these Cl2 are outside the. So what is the
PD
formula then?
NH3 whole 4.
And you have something like this.
Yes,
Okay?
sir. And plus 2. Yes, sir.
So what is the secondary valency?
4.
What is the coordination number? How many ligands are giving lone pair of electrons to platinum?
4.
4. What is the primary valency?
2.
Oxidation state of palladium is 2.
Yes, sir.
Oxidation state.
NiCl.
Okay. What is the next story?
NiH2O whole 6. And it is 2Cl minus. So this is plus 2. Secondary valency will be 6.
6. Okay. Third one.
Third one will be PTCl 4 dot 2HCl. Okay. PTHCl whole 2 4Cl 2. Third one 2.
Huh? Secondary valency will be 2. How?
In third one.
Where? Why? There is no ion outside. What it means? What means? What is the formula?
PTCl 4 dot 2HCl.
Then what is outside? Nothing. So how many are forming? How many coordination number here? 6. There are 4 Cl and
Okay.
they are also giving electron pair to HCl.
Okay.
There's 6. How many are these? 4 plus 2, 6. Nothing is outside. Is there anything outside? No.
Okay. Sir, why didn't we write this third case as PT HCl whole 2 and then 4Cl minus?
That
Like we did in.
we will tell you, we will after I start telling you the nomenclature and naming of that, we are going to do it. Present question is only, there are two type of valencies which we are talking. We have not discussed that point yet. We will come to that in our next classes. Here we are only discussing the two types of linkages, primary and secondary. Okay? Werner's theory. I'm talking of Werner's
Okay.
theory, student. Later on, how to name these compounds, all these things came. That terms we will define after this. Okay? Today's discussion is on Werner Theory
Okay,
of
sir.
coordination compounds.
Compounds.
Okay. The what is the next one?
Next one is COCl3.4NH3. So it will be 4. Uh, 4. Secondary valency will be 4.
Four. Fourth one, 4. COCl3 and 4NH3. Then what is that? CO. You
Ha,
have
okay. There will be only one precipitated. So there will be two inside also. 6. 6. It will be 6.
secondary valency 6 students. Okay. The last one,
Last one, it will be nothing will be out. Nothing will be outside. 6.
6.
No, not 6. Nothing will be outside ना तो यहाँ पे 2 है और यहाँ पे 2 4.
How much?
4.
Okay. Don't answer the question without doing it. That's the point, my point. Always to the students. Are you cannot answer anything blindly, and that is our problem. I mean, I hope you understood the point very clearly.
Yes, sir.
I hope the Werner's coordination theory is very clear to the student now that there are metal ions, transition metal ions have a capability to accept lone pair of electrons in their vacant orbitals. Therefore, they form a lot of complexes, and these are ligands are those which can give the lone pair of electrons to the metal ions, and we represent them in the square brackets. So they are different from the double salts.
Yes, sir.
And there are two types of valencies, primary and secondary valencies, which was proposed by Werner after he had experimental information,
Yes, sir.
because he was able to form more than one compound of COCl3 with ammonia, which proved that there is more than one type of valency, and their properties he studied. Conductivity and number of ions were different, and colors were different. On that
Yes,
basis,
sir.
the was born the coordination or complex compounds. So the worth of complex has been done. We will continue more about this in the next lecture, student. I
Okay, sir.
hope everything is understood by you.
Yes, sir.
Okay, good night.
Okay, thank you, sir.